So in this problem, we have two quadratic equations. The quadratic equation x squared minus 3x plus p. This have got two roots that's specified by a and b. And the equation x squared minus 12x plus q equals to 0 have roots c and d. Now there's a condition that these roots of each of the two quadratic equations a, b, c and d, they form a geometric progression. Then using this, we need to obtain the value of the ratio q plus p to that of q minus p. So let's begin. So we'll start with the first equation. So here we have x squared minus 3x plus p equals to 0. So it's given here that the roots are a and b. Now what will be the sum of roots? The sum of roots, now that was going to be equals to positive 3 from this equation. Then sum of roots, that means we have a and b as the two roots. So a plus b, that value is going to be equals to 3. And then it's given, and then the product of the roots. The product of the roots will be, so product of the roots, that will be equals to p. Now we know that the roots are a and b, so we have a times b, so that's equals to p. We'll label this as equation number 1 and equation number 2. We'll be using this. Then coming to the second equation, we have x squared minus 12x plus q equals to 0. Here also, the sum of the roots, which will be, since the roots are c and d, the sum of the roots c plus d, that will be equals to positive 12. Let this be equation number 3. And the product of the roots, c times d, that will be equals to, so that's q. So the product of the roots will be q. So let this be equation number 4. We'll come back to this in a moment. Now it's given here that ABCD forms a GP. So let the common ratio, we'll have to specify the common ratio because they are in geometric progression. So let the common ratio be R such that A, B, C, D are in a geometric progression, which would mean that B must be equals to A times R. Just take the first term and multiply with the common ratio R. C value will be AR squared and D value will be AR cubed. So we'll substitute this value back in equation 1, 2, 3, 4 to find out some value. So let's use equation number 1 and 3. So let's write it down. So using 1 and 3. So equation number 1, we have A plus B. So that value is equals to 3. And then equation number 3, that gives us C plus D equals to 12. We will substitute this value here. So a plus b, b means a times r. So this is equals to 3. So if we take a as the common factor, so we have a multiplied to 1 plus r. So this is equals to 3. Then we have c plus d, and that's equals to 12. So c is ar squared and d is ar cubed. This is equals to 12. If we take ar squared as the common factor, so ar squared will be multiplied to 1 plus r. So this is equals to 12. So let's denote this as equation number 5 and the other one is equation number 6. Now we can divide equation number 6 with equation number 5. So dividing 6 by equation number 5, so we're going to get AR squared multiplied to 1 plus R whole divided by A times 1 plus R. So this is equals to 12 divided by 3. So we have R squared equals to the 4. So R value will be equals to plus or minus 2. For ease of calculation, let's consider only the positive value of R. So let's say R is equals to 2. So we have obtained the common ratio. So we can use any one of the equation to obtain the value of our first term. So let's use equation number 5. So for 5, equation number 5 gives us, so we have our first term A. So this will be equals to 3 divided by 1 plus R. So we have A equals to 3 divided by 1 plus 2. So that means we have 3 divided by 3 or our first term, that's equals to 1. Now that we have the values of our first term as well as the common ratio, we can easily obtain the value of P and Q. So we'll use equation number 2 and equation number 4. So let's use that. So using equation number 2 and equation number 4. So in equation number 2, we had the product of the roots A times B, that's equals to P. And equation number 4, we had the roots of the second quadratic equation that has a value of q. So a times b, so what's b? B is simply a times r, that's equals to p. And c is a r squared multiplied to a r cubed, so that's equals to q. So we have a squared times r equals to p. And then we have a squared times r raised to the power of 5, so that's equals to q. Substitute these values here. So we have 1 squared multiplied to 2 equals to p. So p value comes out to be equals to 2. And then we have 1 squared times 2 raised to the power of 5 equals to q. The q comes out to be value of 32. So now that we have obtained the value of p and q, let's go back to our original question. So we have to obtain this ratio q plus p to that of q minus p. And now finally q plus p divided by q minus p, so this will be equals to 32 plus 2 divided by 32 minus 2, which will be equals to, so we have 34 divided by 13, 30, so 2 times 17 is 34 and 2 times 15 is 30. So that means our final value is 17:15.